Hello guys, welcome back once again in a new video. So today in this video, I guess you already guessed the topic by seeing this slide, right? Today we are going to discuss about transistor, as well as we will be making different kind of circuits, and we will learn about the transistor in a more depth. In my last video, I have explained you about the diodes, and we have made a lot of circuits on capacitor also, and we have learned about the parallel connection of the capacitor and series connection of the capacitor. So if you have not watched my previous video, I will suggest please watch the last video so that you will get an idea about the diode, because transistor is actually made up of two diodes. So I will just suggest you watch my last video to start with the transistor. So without wasting the time, let's start the transistor. So here you can see what is a transistor. Transistor is actually a semiconductor device which is basically used to amplify and switch the electrical signals. So it has actually two applications. Either transistor can work as an amplifier. Amplifier means, let's say we are saying something in the mic, and the voice which is actually coming out to the speaker is becoming louder. So this is called amplification. In the mic we are giving a low signal, and the voice which is coming out to the speaker is actually becoming louder. So this is called amplification. So transistor can be used as an amplifier, and also it can be used as a switch. Again, for both application there are different kind of real projects which we will be doing in this video. So in this video I will show how it can work as a switch and how transistor can work as an amplifier by showing you one different kind of circuits. Okay, so transistor being active device from the most important part of all the sensors and ICs. So actually in every IC you can find the transistor. Even in the CPU there are millions number of transistors. And here the classification you can see. So basically there are two type of transistor, BJT and FET. So in this video we are going to discuss about the BJT, and BJT are actually current control device, and FETs are voltage control device. So today we are going to discuss about the current control device. So we are going to discuss about the BJT. In BJT again you can see there are two things, NPN and PNP, and in FET also there are two things, JFET and MOSFET. Moving on. Yeah, so as I told, in this video we will be focusing on BJT. So what is a BJT? BJT is bipolar junction transistor. It is a three-terminal semiconductor device consisting of two PN junction. We have already learned about the PN junction in my last video in diode, and PN junction which are able to amplify signals. It is a current control device. So here you can see BJT is a current control device. So we can control the currents using BJT, and FET is actually voltage control device which we will cover in next part of the video. So the three terminals of the BJT are the base, collector and emitter. A BJT is a type of transistor that uses both electrons and hole as charge carriers. Again, we have seen there are two types in BJT, NPN and PNP. So in NPN transistor the majority carriers are actually electrons, and in PNP transistor the majority carriers are holes. So in most of the electronics boards and electronic sensor, NPN is actually being used because electrons are majority in carriers in NPN. So the switching capability will be like very fast in this NPN mode. But in PNP transistor the switching power will be not as much fast. That's why in lot of circuits you can only find the NPN transistor. Then you can see this is the symbol, left hand side, this is actually NPN. So in NPN transistor and PNP transistor both are symbol are same, but there is one difference. If you see the arrow, so this left one is actually NPN, so the arrow is outside, so it is showing the current direction. So here in NPN current flows from collector to emitter. and in PNP it's opposite. Current flows from emitter to collector. So E means emitter and the middle one is base and the upper one is collector. In PNP also you can see emitter, base and collector. So by seeing this thing arrow, you can differentiate between PNP and NPN symbol. Okay, moving on. Yes. So now we will be doing one circuit diagram. So basically this is a diagram which is known as automatic street light. So first we will make this diagram. Again I'm going to use Tinkercad. So far in my last videos also I have used Tinkercad to simulate the circuits. So again I'll be using Tinkercad to explain how this circuit is actually working as a switch. Like in this circuit, transistor is acting as a switch. So let us understand. Let me open Tinkercad. So I'll go to Google and then I'll just type tinkercad.com. So I'm going to create a new circuit. So I will just open new circuit. In the last video we have learned about the diode, and also we have learned how diode works in forward bias and how it will not work in reverse bias, because in the reverse bias it was working as an open switch, and in the forward bias diodes are working as a closed switch. So same thing, because NPN transistor is made up of diodes only, two diodes. So again in this transistor also there will be open circuit and closed circuits, and in the same we have it will work as a switch. And let's see this circuit, automatic street light circuit. So basically the circuit diagram is here, and I'm going to implement this diagram on Tinkercad. So in this diagram also I'll be explaining how to read the circuits. So here you can see this is a symbol of transistor and the arrow represent to emitter. So here first we will also read this diagram. So where emitter is going, this is a symbol of battery, this is a symbol of transistor, and this is a symbol of LDR, which is a light sensor. And this is a symbol of resistor, this is also a symbol of resistor. So in this circuit there are two kind of resistor, 100 kilo ohm, which is very high resistance value, and 330 ohm value, which is for LED, so that LED will not get fused. Okay, so I will just quickly explain about the LDR. So LDR stands by light dependent resistor. So by the name it is very clear, light dependent resistor are a sensor which resistivity is totally dependent on the light. If it's daytime, if light is falling on the sensor, then resistivity of this LDR will be decreased, and if there is night time, if there is no light, the resistivity of this LDR is going to increase much faster, like it will be very high. So here LDR is connected at base, and another end of LDR is actually going to negative. So first connection we are going to take transistor, and we are going to make emitter negative, because here you can see clearly emitter leg is actually going to negative of the battery. So let me take the components. So I will use power supply bench here. Okay, so I have taken transistor, LDR, and then I need a LED also, and we need resistors. So here is our LED. Now let me take resistor. Okay, resistor is also here. So now we have taken all the components. In resistor we need two. One is 100 kilo ohm and another we need 330 ohm. So let me copy this and paste. and I will just change the value of this one 330 ohm. So here, yes, that's it. Now first thing is we have to make ammeter negative, which we have seen in the circuit diagram. So I'm going to make ammeter negative. That's it. Now moving on. So ammeter, you can see the diagram, ammeter is going to negative. We have done this. Now we have to connect LDR. One end of the LDR we have to connect to base. Another end of the LDR is actually going to negative of the battery. So let's do the connection. One end of the LDR we have to connect at base. Another end of LDR we have to connect to negative leg of the power supply or battery. Okay, so LDR is done. Now let me do these things black in color because these both are actually going to negative. So I will just make this color black, which means both terminals are actually going to negative of the battery. Now we have to connect 100 kilo ohm resistor. One end of the 100 kilo ohm is actually connected to base. Another end of 100 kilo ohm is actually going to positive of the battery. So it's very simple. I will take this 100 kilo ohm. One end of the 100 kilo ohm I have to connect to base. Another end is actually going to positive of the battery. In this case, it's power supply. Because this is positive, I will change the color red. This, let us make this green only. Okay. Yes. Now again, so we have connected 100 kilo ohm, we have connected LDR, ammeter connection is also done. Now we have to connect negative leg of LED to collector. Here you can see the upper one is positive leg of LED and down one is negative. So negative leg is connected at collector. So let me take this thing. This is cathode. Cathode is negative leg. So negative I have to connect to collector. So it's connected. Now positive leg of LED is connected with 330 ohm resistor. So I will take this resistor and I will just connect to positive leg of LED, which is anode. And the another end of the resistor is going to positive of the battery. So I will just connect this to the positive of the battery and I will change the color red. So that's it, we have done the connection, and let me show the simulation, then I will explain how this circuit is working. Before that, let's set the voltage. So here I have put it 5 volt. Let me give 9 volt. Okay, and let's start the simulation. Okay, so what you can see here, the LED is glowing because you can see the LDR is in night mode. So LDR sensor is detecting darkness. That's why the LED is glowing. If I will just scroll this by side, if I switch to day side, you can see the LED is getting off automatically. If I switch this to darker side, then you can see LED will glow. So that's why this circuit is called automatic street light, and that's what happened in the street lights. In the street lights there are 1000 number of lights, and as well as on the highway you can see there are many numbers of headlights, right? So what do you think, any person is appointed there to turn on and turn off those lights? Right? Not like that, right? So what people can do? People have used sensors so that in the daytime automatically all the lights will be off, and in the night time, during night time, automatically all the highway lights will turn on. So that is the application of the automatic street light and LDR sensor. Here you can see in the daytime LED is automatically getting off, in the night time automatically it is turning on, because LDR is light dependent resistor. In the daytime the resistivity of the LDR will be decreased, and in the night time the resistivity of the LDR will be increased. Now let me explain the circuit, how exactly this scenario is happening. Okay, so I will just open the slide. So we have seen the simulation and we have noticed in the night time only the LED is turning on. In the daytime it's not turning on, it's turning off. Okay, so in NPN transistor current flows from collector to emitter. It flows from collector to emitter. So first the current will come here, and in daytime what happens? In daytime the resistivity of the LDR will be very low, and current always follow low resistance path. So in daytime what happens? Current will come here, and at the base the input voltage will not be sufficient to turn on the transistor, and transistor will be in open state, open switch. So in the daytime, during the daytime, transistor will be in open state and the LED will be off. But in the night time what happens? In the night time the resistivity of the LDR will be much higher, and it will not let the current pass through this, and the voltage which comes at the base is sufficient to trigger the transistor, and it will turn on the transistor, and whatever is connected at collector, here in this case LED is connected, so it will be turned on. If you connect buzzer also, it will start buzzing during the night time. So I hope you have understood the circuit diagram. If you have still any doubt, you can put your comment, and then we will help you to resolve your problem. Okay, so I hope till here there is no problem. We have seen this diagram. Now we have seen how transistor work as a switch. Now I will explain how transistor work as an amplifier. And as I told, we have to give 0.7 volt at the base, then only it will start working and transistor will be closed circuits. So let me explain that things also, because here in this circuit we have not seen whether we are applying 0.7 volt or we are applying less than voltage. So what I can do here, I will just take multimeter and let's measure the voltage during the daytime and as well as in the night time, so that we will make sure that yeah, we are applying 0.7 volt and then it is making closed circuits. So let me stop simulation, let me take multimeter. Okay, so I have taken multimeter here. So we have to measure voltage across emitter and base junction. So positive, I will connect to base, and negative I will connect to emitter. And let me change the color, black. Okay, let's start simulation again. Here you can see 709 millivolt, which is actually more than 0.7, that's why the LED is on. Let me do the brighter side, and you can see the LED is actually turning off because the applied voltage at the base is less than 0.7 volt. So it means we have to apply 0.7 volt at the base, then only transistor will be closed circuit, otherwise it will be open circuit and your device will be not on, whatever you will connect at collector. Here you can see 466 millivolt, which is actually less than 0.7. But if I again scroll beside, here you can see it's more than 0.7 and LED is on. So we have verified this thing also. Let me stop simulation, and now let's do the another circuit, how transistor work as an amplifier. So let me open this. Yes. So basically this is the diagram which we are going to implement now. But before that, let me explain this circuit. So as I told, we have to apply at least 0.7 volt, then only transistor will be in closed circuit, closed state. So here you can see at the base we are actually going to test these two wires. So manual intervention is there, and if you test the wire, our body resistance, human body resistance is actually very high. So what happens if you touch the wire, the 9 volt is actually coming from here, but the body is very high resistance, so the voltage which comes at the base will be 0.8 volt approx, and then that will give trigger to the base and the LED will be turned on. That's why this circuit is called touch switch, because here you are going to touch and then only LED will be on. So this project is very interesting, because in this project what happens, 2 to 4 people can actually hold their hands and they can touch the probes, they can touch the wires, both end of the wires, and the LED will get on. But if any continuity will not be there, then it is not going to glow. Now let's do this and let us understand in a better way. So let me delete this. LDR is not required, so I will just delete the LDR. We don't need this also. Yes, of course we need resistor 330 ohm, or I'll do one thing, I will just delete all of them. Yes. Now let me take transistor again. So here is the transistor NPN. So you can see this is NPN transistor BJT. Okay, now we need one resistor also. So I'll take one resistor. I will give a value 470 ohm. 470 ohm. That's it. And because here we have to touch, so instead of human intervention, I'll just use a switch. Okay. So now yes. So here what happens here, we will provide very low voltage at base, which is approx 0.7 volt to 0.8 volt, and we are going to get at collector much higher voltage. It will be 3 volt around, like maybe at some point of time it will be 2.5 also, and that voltage will be enough to turn on this LED. So we are applying just 0.7 volt and we are getting 3 volt, 2.5 volt at collector. So we can add 2-3 transistor and we can amplify these signals, because one transistor is making 0.7 volt to 3 volt. So if you connect 3 transistor, you can easily achieve till 9 volt. So again, in this transistor, emitter is going to negative. So first thing is I will make the emitter negative, and at the base we have to apply voltage. So as I told, we have to apply 0.7 volt. So switch is not required. I will just apply the voltage by this power supply bench. So I will connect to positive. So at the base, as I told, I will apply 0.7 volt and it will start working. Okay. Now I will connect LED. So let's see the diagram. In the diagram you can see the minus of the LED is connected to collector. So let me connect minus of LED to collector. So here I will connect to collector. I will change the color black, minus of LED, and then plus of LED is connected with 1 kilo ohm resistor, but I have used 470 ohm. So let me do 1 kilo ohm only. One kilo ohm. Yes. Okay. I will connect here, and then another end of 1 kilo ohm is actually going to positive. So I will connect to positive and I will change the color red. That's it. It's very simple. And also let's measure the voltage across emitter and base junction. So I will connect positive at base and negative of the multimeter probe I will connect to emitter. Okay. So here I have connected multimeter across emitter base junction and I am going to give positive voltage. As I told here, I am going to give 0.7 volt at base and we are going to see whether this LED is glowing or not. And you know one thing, for glowing an LED at least you should give 2 volt, then only it will glow. Here in this case we are providing 0.7 volt at the base and we are going to get more than 2 volt at collector. So let's see that. Now I am going to start the simulation. Okay, so what you can see here, we are actually providing 905 millivolt at base, but also we have to connect the emitter and collector because collector and base is positive. So let me connect this to positive. One more, actually we need one more, this thing. We need one more power supply. So let me take one more because I have not connected battery, or we can just directly take a battery. That will also solve the purpose. So battery we have to connect at emitter and then collector. That's it. Let me see these things. Okay, emitter is actually going to negative, collector we have to give 9 volt, then only we can do these things. So let me stop simulation, and the applied voltage here, because this is connected, let me delete this. For base voltage we will separately take another power supply. Here let's apply 9 volt only, which we have seen in the diagram. Collector is positive and yes, so we are applying 9 volt and at the base nothing is connected at base. Let me take another power supply. Yes, with this power supply we will give voltage at base. So let me connect to base and let me change the color red because this is positive, and this we are going to connect at emitter and let me make it negative. With this we will give voltage. So as I told, 0.7, yes, and with this we are providing the circuit voltage which is 9 volt. Let me start simulation, and what you can see, the LED is actually glowing, started glowing, and if I decrease this voltage, the LED is turning off. It means it is clear. You can see here, when I am providing 0.7 volt across emitter and base junction, then the LED is turning on, and if I am providing less than that, the LED is not turning on. So the thing is, the key point is we have to provide 0.7 volt at the base in order to get 2.5 volt or 3 volt at base collector junction. Here you can see, if it is less than 0.7, then it's not turning on. I hope you have understood these things. If still you have any doubt, put your comment. Okay. So with this circuit, I have explained how transistor work as an amplifier, and in the previous circuit we have seen in the automatic street light circuit we have seen how transistor works as a switch. So I hope this things is much simpler way to explain the both things, transistor as a switch and as an amplifier. That's why I took two circuits, and both circuits were like very simple to understand. And by this, in this video, I hope you have clear idea like how to read the diagram, how to read any kind of circuits, and how to implement those circuits on breadboard or on puff board actually. So again I will just explain. So here emitter is going to negative. At base we have to connect one wire. Another wire is actually coming from positive of the battery, and at the collector you have to connect LED. Negative leg of LED is connected at collector. Positive leg of LED is connected with 1 kilo ohm resistor, which is again going to positive. And if you touch the wire, in that case you are going to give more than 0.7 volt at base, and then your LED is going to glow. In NPN transistor there are two sides. If you see visibly the BC547 transistor, it looks like this, and it has two sides, flat side and curve side, flat side and curve side. So from the flat side, if you are keeping the flat side in front of you, from the flat side the right leg is emitter, the middle one is base, and the left leg is collector. Emitter right one, middle base, left is collector. Always remember these things, because I have seen many of the people are doing the mistakes. Lot of time they make the reverse connection, wrong connection. Due to that, transistor will start hitting, and that is actually very wrong. It is going to damage your all the other component, and it is going to make a bad impact on your circuits, on your microcontroller boards or on the others boards. So while doing the connection, make sure you have checked all the data sheet of the specific transistor. Depending on the part number, there are these pins can be vary, emitter, base and collector. Sometime in some transistor emitter will come on the left hand side. So before using any transistor, do check the data sheet for the proper voltage rating and proper current rating. So in this video I have explained two things, how transistor work as a switch and as an amplifier. So I hope you have a clear idea about the transistor now. So with this point I'm going to end this video. So if you are new on this RoboPlanets channel, if you are watching this video first time, do like and subscribe to our channel and put your comments in the box, so that we can make the